In this presentation, I am going to explain about how to measure the three parameters of the transistor, NPN transistor. To measure the three parameters of the transistor, we are going to use this apparatus. In this apparatus, there are four meters are used. Two voltmeters are there and two ammeters are there. This is the voltmeter. That one will measure the voltage across base and emitter, that is VBE. This is the voltmeter that is used to measure the voltage across collector and emitter. Therefore, it should be called as VCE. This is the microammeter. That one will measure the base current. Base current will be usually very small. That's why we are using microammeter. So therefore, it measures IB. Here another ammeter is there, milliammeter is there. This one will measure the collector current, that is IC. Here, to adjust either VBE or IB, this knob must be used. By adjusting this knob, we can vary the value of either VBE or IB can be varied by using this knob. Are you clear? Here one more knob is provided here. With the help of this knob, either we can adjust VCE. Are you clear? That VCE that can be varied with the help of which one? This knob. Here the transistor, NPN transistor, that is connected internally. The transistor, it has got three ends. Three terminals are there in the case of transistor, that is shown in the photo. They are called as emitter, base and collector. Emitter, base and collector. As per the circuit diagram, the connections are, peripheral connections are given in the board. Are you clear? By using this board, by adjusting the various voltage values and current values, we are able to measure the three parameters of the transistor. So that one will be taught in the next successive presentations. Here look at the voltmeter. This is the voltmeter. That one measures the voltage across collector and emitter. There the value of VCE is kept constant as 5 volt. Don't forget this. Throughout the experiment, VCE value should not be altered. The important parameter of the transistor is input impedance. The input impedance parameter of the transistor can be found out by drawing the graph called input characteristics curve. Are you clear? While measuring the input impedance, which one must be kept constant? VCE must be kept constant. What is VCE? VCE is called voltage across collector and emitter. The voltage across collector and emitter must be kept constant. Its value is set as 5 volt here. Throughout the experiment, the value of VCE should not be altered. Now, the VBE, voltage across base and emitter, must be changed, and the corresponding variation in the microammeter. Are you clear? Here we are measuring the base current. The base current is measured in the microammeter. No, that should be noted. So therefore VBE should be altered, IB to be noted. Now I am going to vary the value of VBE. Look at the graduation. Now first I am going to set the value of VBE as 0.1 volt. Now it is kept exactly at 0.1 volt. Note down the reading in the base current. In the case of base current IB, no change. Therefore it should be taken as 0. For 0.2, for VBE 0.2, note down, the reading is still 0. IB is 0. For 0.3, what is the reading here? Again it shows 0. IB is 0. For 0.4, VBE 0.4, what is the value of IB? Again it shows 0. 0 microampere. Now it is going to be increased from 0.4 to 0.5. Now the VBE value is 0.5 volt. What is the reading again? IB value is 0. Now it is increased from 0.5 to 0.6. Now there is a small change is there in the deflection. Now it is coinciding with third division. Its least count is 5. Microammeter least count is 5. Therefore 3 into third division into 5 is 15. 15 microampere is the IB value. Note down. Now the value of EB is increased from 0.6 to 0.7. Now it is increased from 0.6 to 0.7. Note down. Now the reading is, it is exactly coinciding with the very important thing is, without any parallax error we have to set the values. Are you clear? Now it is exactly at 0.7 volt. It is coinciding with 28th division. So 28 into 5, how much? 140. 28th division is coinciding, least count is 5. 28 into 5 is 140 microampere is the IB value. So like that we have to measure the, which one? The both voltmeter reading and ammeter reading. Here which one is kept constant? VCE is kept constant. Understood? Now we are going to calculate the input impedance of the transistor. Already by using the tabulated values, the graph is being drawn. In x-axis the VBE values to be taken. In y-axis base current IB are taken. By using the tabular column values, all the values are plotted and the graph is drawn. So after plotting all the values, after connecting all the points, you will get the graph like this. The shape of the graph, it will be like this. Now to calculate the input impedance, the formula is Ri is a symbol for input impedance. Ri is equal to del VBE divided by del IB. This is the formula. Del VBE means difference in base and emitter voltage. What is del IB? Difference in base current. In between these two, the ratio to be taken. Del VBE. How to calculate del VBE? Look at the graph. Here in del VBE, find out the maximum value. Here if the graph, the values are, after plotting the values, we have to draw the slope. I have drawn the slope here. Just you extend the line towards x-axis. This is the maximum value of VBE. After intersection, you will get the maximum intersecting point here. That is called, what is this? This is a maximum value. What is the maximum value here? 0.65. And look at the minimum value, intersection value. There you will be getting 0.62. Okay. Look at the difference in IB. What is the maximum value? 80. Here if it is extended, you will get the minimum value of IB, that is 40. So 80 minus 40 is a difference in value of IB, that is del IB, that is measured in microampere. Now you have to subtract. Now after subtraction you will get 0.03 volt. Okay. So after that, that is to be divided by which value? The IB value. Subtract, you will get 40 micro ampere. Okay. Now calculate 0.03 divided by 40. The answer will be 0.00075. 0.00075. Here it is given in terms of microampere. Okay. So I'll extend the value 0.03 volt whole divided by microampere can be converted into ampere. 40 into 10 to the power of minus 6. If it is brought up, that one becomes 10 to the power of 6. After multiplication, you will get 750 ohm. 750 ohm is the value of Ri. This is called as, what is this? Input impedance. Okay. So this is the method of finding the value of input impedance. Now we are going to measure the current gain of the transistor. In the case of determination of the current gain, we have to draw the graph called transverse characteristics. Okay, while drawing the graph for transverse characteristics, which factor must be kept constant? Again, we have to keep this VCE as constant. In the previous parameter measurement, that is input impedance measurement, which factor was kept as constant? VCE was kept constant. Again, even while measuring the current gain, again VCE must be kept constant. It should be kept exactly at 5 volt. So without altering the value of VCE, we have to find out the value of which one? The current gain. Okay. Don't forget VCE value must be kept constant while determining the value of current gain. Now we are going to determine the value of current gain of the NPN transistor. To find out the current gain of the NPN transistor, already I have told that VCE must be kept constant. Its value is 5 volt. That should not be altered. Now I am going to vary the value of IB. Are you clear? This IB value to be altered, base current to be altered, that should be measured in terms of microampere. If you vary the value of IB, there will be a corresponding change in the collector current IC, that is measured in terms of milliampere. First I am going to set the value of IB. The first value will be how much? 10 microampere. Okay, note down the reading. Here slowly, if it is varied, you can see some change. Now it is exactly kept at which value? 10 microampere. Okay. Now you have to find out which reading is coinciding here. Are you clear? Here 10 microampere is there in IB. Look at the IC value, corresponding IC value. It is coinciding exactly at 7th division, 7 into 0.25. Least count of the milliammeter is 0.25. 7th division into 0.25 is 1.75. Note down. Now I am going to vary the value of IB. It is increased from 10 microampere to how much? 20. Are you clear? Now it is in 4th division, 4 into 5, 20. Are you clear? Now note down the corresponding reading. Are you clear? If there is a small change in the base current, that one will create a greater change in the collector current. Therefore, we have to set the base current in a very accurate manner. Now it is exactly at which division? 4th division, 4 into 5, 20. Look at the reading here. It is coinciding with 16th division. 16 into 0.25, 4. 16 into 0.25, 4. 4 is the milliammeter value. Note down. Now it is increased from 20 microampere to 30. It should be kept exactly at the 6th division. Now it is at 6th division. 30 microampere is set here. Note down the reading here. It is exactly coinciding with 22nd division. 22nd into 0.25, 5.5. Note down the reading. IC value. IC value is how much? IC value is 5.5. Now it is increased from 30 to 40. It should be kept exactly at the 8th division. Are you clear? 8 into 5, 40. Here note down the reading. It is exactly coinciding on 30th division. 30 into 0.25, 7.5. So 7.5 is the value. Okay. 7.5 is the value of which one? IC. Here 40 microampere. For that, what is the value of IC? 7.5. So note down all the reading and draw the graph between IB and IC. Draw the slope. You will get the answer. Okay. Now in the transverse characteristics, we are going to calculate the second parameter of the transistor. Look at the formula here. To calculate the current gain beta, we have to use the formula del IC divided by del IB. That is the ratio of change in collector current to the change in base current. From the graph, here IB values are taken in x-axis IC values are taken in y-axis, IB values are measured in terms of microampere, IC values are measured in terms of milliampere. From the tabular column, all the values are plotted. You will get a straight line. After getting the straight line, we have to draw a slope. You can take the slope anywhere in the graph. Here, look at the value. We have to find out the change in IC. In the case of IC, find out the maximum value from the graph. The maximum value intersecting point is 5.5. That is written here. After that, find out the minimum value. The intersecting point is 3. 5.5 minus 3 is written in the numerator. That should be measured in terms of milliampere. After that, from the slope, the lines are extended towards the x-axis. Find out the value, maximum value of IB, that is 30. Here the minimum value is 16. Okay, minimum value is 16. So the values are substituted here, 30 minus 16 microampere. Now find out the difference. Here the difference is 5.5 minus 3. After getting the difference, you will get how much? 2.5. 2.5 into milliampere must be converted into ampere, 10 to the power of minus 3 ampere. Okay, and then write the denominator value. The denominator values are 30 minus 16. The value is 14. 14 into 10 to the power of minus 6 ampere. Now find out the division calculation. 2.5 divided by 14. 2.5 divided by 14 is 0.175. So 178. 2.5 divided by 14 value is 0.178 into 10 to the power of minus 3 into, if the value is brought up, that one becomes 10 to the power of minus plus 6. Okay, minus 6 becomes plus 6. So after simplification, you will get 0.178 into 10 to the power of 3. So after simplification, you will get 178. In the case of current gain, there is no unit. This is the ratio between two currents, collector current and base current. Therefore, there is no unit to calculate the current gain. So this is the value of current gain of the NPN transistor, given NPN transistor. So this is the second parameter to be calculated. Okay, these values are very important while constructing the amplifier circuit. Okay, using transistors. Now we are going to measure the third parameter of the transistor. The third parameter of the transistor is called output impedance. To calculate the output impedance, what we have to do? We have to vary the value of VCE. VCE means voltage across collector and emitter to be varied. The corresponding collector current to be found out. IC to be found out. Okay, but which one should be kept constant? The IB value. This is nothing but microammeter in which IB can be read, and IB value should be kept constant. Are you clear? Now what I am going to do, by adjusting the knob, first I am going to keep the value of IB as 20 microampere. Look at that. I am slowly varying the IB value. It is kept exactly at 20 microampere. Are you clear? The IB value which is shown in the microammeter is 20 microampere. This one must be kept constant throughout the experiment. Are you clear? When VCE is varied, when IC is noted, IB value should be kept constant. What is the first value of IB now? 20 microampere. Okay. Now I am going to take the first set of reading. So in the first set of reading, IB value is 20 microampere. That is kept constant. Okay. Its value should not be altered. Now this is the voltmeter of range 1 volt. This voltmeter to be used to measure the VCE, that is voltage across collector and emitter. This is to be varied. The corresponding change in the IC, that is in milliammeter, must be noted. Now I am going to vary the value of VCE. Now the VCE value is 0.1 volt. It is slowly increased from 0.10 to 0.1 volt. Are you clear? Very patiently you have to do this. It is kept exactly at 0.1 volt, and in the meantime often you have to check the IB value whether it is exactly at 20 micro ampere or not. That should be checked. Now note down the reading in the milliammeter IC value. That is exactly coinciding with the fifth division. Okay, sixth division. 6 into 0.25. 6 into 0.25 is 1.5. Therefore, for 0.1 volt VCE, the corresponding reading in the milliammeter is IC is how much? 1.5. Are you clear? This is a very important value. 1.5 milliampere is the value. Now I am going to increase the value of VCE from 0.1 to 0.2. Look at the value. It shows 0.2 volt. Often you have to check the IB value. It should be kept exactly at 20 microampere. Often you check it up. Note down there is a sudden increase in the IC. It is coinciding with 15th division. 15 into how much? 15 into 0.25 is 3.75. So 3.75 is the IC value now. Now I am going to increase the value of VCE from 0.2 to 0.3. Okay. Note down the reading. Is there any change? No change. Again it shows 3.75. Are you clear? For 0.3 also the value of VCE is 3.75. Now I am increasing the value of VCE from 0.3 to 0.4. Note down the reading, no change in the reading. Again it shows 3.75 milliampere. Okay. Now I am going to increase the value of VCE from 0.4 to 0.5. Again there is no change in the IC. Are you clear? Again it shows 3.75. Now it is increased from 0.5 to 0.6. 0.5 to 0.6. No change in the IC value. Again it shows 3.75. It shows that transistor, it has attained the saturation region. Now the value is changed from 0.6 to 0.7. The value of IC is 3.75. Note down the reading. Now the value of VC is increased from 0.7 to 0.8. Now note down the reading in IC. No change. Again it shows 3.75. Okay. Now it is increased from 0.8 to 0.9. 0.8 to 0.9 VCE value. Note down the corresponding reading here IC. Again it shows 3.75. Now it is increased from 0.9 to 1 volt. Here look at the value, though no change in the IC value. Again it shows 3.75. So I have taken the first set of value when the IB was kept at how much? 20 microampere. Understood? Now we are going to take the second set of reading. Now the IB value should be kept at 40 microampere. Throughout the experiment, the IB value should not be altered. Now I am going to vary the value of IB. Look at that. Slowly the IB value increases. It should be kept exactly at 40 microampere. It is exactly kept at 8th division. 8 into 5 is equal to 40 microampere. Throughout the experiment, the IB 40 microampere should not be varied. It should be kept constant. Okay. Now I am going to take the second set of reading. Now the IB value is kept at 40 microampere, that should be kept constant. Now I am going to vary the value of which one? That VCE. Okay. So when VCE is varied, there will be a corresponding variation in the IC. Now slowly vary the value of VCE. Now it is kept exactly at 0.1 volt. Very patiently you have to do that. Okay, now it is kept exactly at 0.1 volt. Often you check whether the IB is kept exactly at 40 microampere or not. What is the value of VCE? 0.1 volt. IB value is 40 microampere. After that, you take reading in IC. Are you clear? Now note down the reading here. Now the IC value is how much? It is coinciding with the 11th division. 11 into 0.25, 2.75. Are you clear? 2.75 is the IC value. Now it is increased from 0.1 to 0.2. Again you check the IB value. IB value should be kept constant at 40 microampere. Often you check the IB. That is very important. Now look at the reading here. Which division is coinciding in IC? Which division is coinciding? 10, 20, 25. Are you clear? 25th division. 25 into 0.25. 25 into 0.25 is 6.25. Understood? Now it is increased from 0.2 to 0.3. Are you clear? Again you check the IB value. It should be kept exactly at 40 microampere. It is at 0.3 volt. IB is at 40 microampere. Note down the reading now. 10, 20, 30. 30 into 0.25, 7.5. Understood? Now slowly increase the value from 0.3 to 0.4 volt. VC is kept at 0.4 volt. Are you clear? IB is also at 40 microampere. What is the value of IC? IC value is 7.5. Are you clear? Now it has attained the saturation region. Now it is increased from 0.4 to 0.5. 0.4 to 0.5. Again the reading IC value is 7.5. Are you clear? Now it is increased from 0.5 to 0.6. IB value is, VCE value is 0.6 volt. What is the value of IC? Again it shows 7.5. Are you clear? Now it is increased from VCE is increased from 0.6 to 0.7. Look at the value of IC, 7.5. Now it is increased from 0.67 to 0.8. Again the value of IC is 7.5. Now the value of VC is increased from 0.8 to 0.9. Again note down the value of IC, 7.5. Now I am going to take the final reading. Now it is kept at 1 volt. Okay. Look at the reading. IC value. VCE value is 1 volt. IC value is 7.5. Okay. Now we are going to take the third set of reading. Now the IB value should be kept at 60 microampere. Throughout the experiment, the IB value should not be varied. It should be kept constant. Now I am going to vary the position of the knob. Slowly the IB value, it starts increasing. It should be kept exactly at 60 microampere. It is kept exactly at 12th division. Okay, look at the reading. 12 into 5 is equal to 60 microampere. Throughout the experiment, the IB value 60 microampere should be kept constant. Okay. Now I am going to take the third set of reading. Now the IB is kept at 60 microampere, that should be kept constant throughout the experiment. Now I am going to vary the value of VCE. Now VCE is going to be kept at 0.1 volt. Very patiently you have to vary that. Look at that. VCE value is how much? 0.1 volt. Often you check the IB, it should be kept exactly at 60 microampere. Now note down the reading here. Now it is exactly coinciding with 14th division. Are you clear? So 14 into 0.25 is 3.5. For 0.1 volt, IC value is 3.5. Are you clear? Now I am going to increase the value of VCE from 0.1 to 0.2 volt. Look at that. Now you check the IB value often, that should be kept exactly at 60 microampere. Note down the reading here: 10, 20, 30. It is coinciding with 35th division. 35 into 0.25. 8.75 is the reading. 8.75 is the reading. Now it is going to be increased from 0.2 to 0.3. It is kept at 0.3. Look at the value. It is kept at 0.3. Check the IB value often. Note down there is a sudden increase. 10, 20, 30, 40, 42. 42nd division is coinciding. 42 into 0.25 is 10.5. Are you clear? Now I am going to increase the value of VCE from 0.3 to 0.4. Okay. It is kept at 0.4. Note down the reading again. Note down the reading here. Which reading is coinciding? 10, 20, 30, 40, 43rd division is coinciding. Okay. 43 into 0.25. 10.75. Now it is going to be increased from 0.4 to 0.5. Which value? VCE value. Look at that. Here VCE is increased from 0.4 to 0.5. Look at the value. No change in the IC. Again it shows 10.75. Now I am going to increase the value of VCE from 0.5 to 0.6. Now note down the value. No change in the IC value. Again it shows 10.75. Now I am going to increase the value of VCE from 0.6 to 0.7. Look at the value. Now it shows 0.7. Note down the IC value here. Again it shows 10.75. It shows that the transistor, it has attained the saturation region. Now it is increased from, VC is increased from 0.7 to 0.8. Note down. Okay. Note down the reading in IC, in millimeter, no change in the reading. Again it shows 10.75. Now it is increased from 0.8 to 0.9. VC value is 0.9. Look at the value in IC, no change. Again it shows 10.75. Now I am going to take the final reading. Now the value of VC is 1 volt. Look at that. The value of IC is 10.75. So no change in the IC value. Okay. Now we have completed the third set of reading, in which IB was kept at 60 microampere. That one was kept at constant. So far we have taken 3 set of reading. For those 3 set of reading, we have to draw the graph. Therefrom we have to find out the value of output impedance. We have to draw the slope also. Understood? Here we have tabulated all the values which are taken for various values of IB values. Now we are going to calculate the output impedance of the given transistor by using this formula RO is equal to del VCE divided by del IC. Del VCE means difference in or change in collector emitter voltage. Del IC means difference in or change in collector current. By using this formula, we are able to calculate the output impedance. From the slope, that is from the graph, del VCE could be calculated. Here the maximum value of VCE minus minimum value of VCE to be substituted. Their values are 0.5 volt minus 0.26 volt. So this is the value of difference between maximum value of VCE and minimum value of VCE. After that, find out the value of denominator, the difference between the maximum value of IC and minimum value of IC to be found out from the graph, that is from the slope. The value is 10.8 milliampere minus 10 milliampere. So the values are given in terms of milliampere. So RO is equal to, find the difference, you will get 0.24 volt, okay, divided by, the difference is 0.8 milliampere, 0.8 milliampere, okay. So find the difference. After that you substitute the values. If you calculate this part alone, you will get 0.3, okay, 0.3 divided by, it is in terms of volt, milliampere can be converted into ampere, 10 to the power of minus 3 ampere. After that, 0.3 can be written as it is, and then 10 to the power of minus 3, if it is brought up, that one becomes 10 to the power of plus 3. Volt per ampere is equivalent to ohm. So RO is equal to 0.3 into 10 to the power of 3. After simplification, you will get the answer as 300 ohm. So this is the value of output impedance of the given transistor, okay.